Well, here we are again. This time we're going to be working on factoring by grouping. Now, this is going to look familiar to many of you, especially if you've already worked with the AC method. And again, you remember we had the squiggly line method in there. This is going to be along the same lines. So the first thing we want to do is we want to see how we're going to group this stuff. And when you look at our original problem, you can see we have 3x to the third minus 4x squared plus 9x minus 12. We can group it just how it is. And this is where we would put in that squiggly line. You remember that. And then we're going to look at this first part. When we look at the 3x to the third minus 4x squared, we want to find out what is the GCF? What is the greatest common factor that we have with those two terms? And the greatest common factor we have is going to be x squared. So we're going to take that out front. And then we'll put what's left over back inside the parentheses, and that's going to be our 3x minus 4. Now, when we look at the second part, we have a positive 9x minus 12. Hopefully, we can see from that we can factor out a 3. If we take out a positive 3, that leaves us with 3x minus 4. And again, when you see this, and you recognize that both sets of parentheses that you've created are the same thing, that's one of those good signs. That's when you kind of feel like, yep, I'm definitely doing this right. I got it going. So then we're going to write what our two factors would be. And remember, the parentheses are going to be one of your factors. So that 3x minus 4 is going to be one of your two factors. And then whatever is not in the parentheses, in this case, this x squared and this positive 3, that's what's going to go in your other parenthesis. So our other factor is going to be x squared plus 3. And we are finished, but it's always a good idea to check those two factors and make sure that you can't factor again. Because later on, there are going to be problems where you're going to factor it, and then you're going to have to factor it again. So it's always a good idea to check to see if you can factor it again. And in this case, clearly we can't. So that's going to be the end of this problem. Right, well, if you're looking at this problem, you should notice something. This is the same problem. When you look at it, that's set up in this way, the way that it is originally. Okay, it's exactly the problem that we just did. But what I've done is I've just rearranged a couple of the terms to show you what happens when you have to do factoring by grouping, and you see it a different way than the way other people are doing it. I know this was an experience for me. There's a lot of times where I would see something and I'd say, I think it factors better this way. So that's what I would do. And in this case, this one makes sense. If you look at it, we would put our squiggly line in here this time, like that. And now our first two terms are going to be 3x cubed plus 9x. And our common factor in those two terms is going to be 3x. And what's going to be left this time is going to be x squared plus 3. And then when we look at our last two terms, negative 4x squared minus 12, we can see that negative 4 is the common factor, and we're left with x squared plus 3. So now when we write out our factors, again, you're looking at this and you should be able to see that what's in the parentheses here is the same as what's in the parentheses here. Which again, that's always that good sign that you get that good feeling like, yep, I'm doing this right. So here goes our x squared plus 3. And then everything else that's not in the parentheses, as you can see, we have the 3x here and the negative 4. That's going to be our second factor. So as you can see, it doesn't matter which way you do the problem. You're going to get the same answer. It's a matter of which factor you have first. But again, it really doesn't matter because you're multiplying. Multiplication is commutative, so the order is really not important. Let's look at another example. Here's another example. We have 2x cubed plus 5x squared plus 4x plus 10. Well, again, if we look at it, we can factor it just like it is. Our squiggly line, we go right in here, breaking it into two parts. And now we look at 2x cubed plus 5x squared. Our common factor there is going to be x squared. So the x squared is going to come out front. And that leaves us with a 2x and a positive 5. And then we look at the second two terms, our positive 4x and positive 10, and we can see that, hopefully, we can see that a positive 2 would come out and leave us with a 2x plus 5. From that, we should be able to see, now, again, when we look at it, we look to see that both sets of parentheses have the same factor, which they do. So that is one of your factors. That's going to be your 2x plus 5. And the other factor is going to be the stuff that's left over, which is going to be x squared plus 2. Just like